This is the EdExcel GCSE 9-1 Maths Paper 3 from the November 2017 series, and it's from the higher tier, and it's a calculator paper. Question number 1. The table shows information about the heights of 80 children, and for part A, we have to find the class interval that contains the median. Well, first thing we need to do is find the cumulative frequencies. So if we find the cumulative frequencies, we begin with the 4. 4 plus 11, that's 15. 15 plus 24, that's 39. 39 plus 22, that's 61. 61 plus 19, that's 80. Now, we can find the position of the median by working out n over 2. So we've got n over 2 tells us the position of the median. So we've got 80 divided by 2, which is 40. So the 40th value lies in between here and here. Of course, we take the next one up, so therefore we can see that the median lies in this interval here. So the median is 160, which is less than h, which is less than or equal to 170. And now for part B, we have to draw a frequency polygon for the information in the table. Before we do anything else, we need to find the midpoints. So the midpoint of this first interval, that's 135. Midpoint of the next interval, that's 145. Midpoint of the next interval, that's 155. Midpoint of the next interval, that's 165, and midpoint of this final interval, that's 175. So now we need to plot the midpoints. So first of all, for 135 we've got a frequency of 4. So we start off here somewhere, and then if we join that up to the next point, for 145 we've got 11. So 135, 4, that joins up to 145, 11. That goes over here. We then join this point up to 24 with 155, so 155 is here, and then we join this up to 24, so here we've got 21, 22, 23, 24. Next one, we join 165 to 22. 165 is here. We join this up to 22. So 22 is over here. And then we join 175 to 19. So 19, that goes over here. So we join these points up like so. So here is our completed frequency polygon, and if you want, you can emphasize the different points as we see here. Question 2. In London, 1 litre of petrol costs 108.9 pence. In New York, 1 gallon of petrol costs $2.83. 1 US gallon is equal to 3.785 litres, and £1 is equal to $1.46. And we're asked in this question, in which city is petrol better value for money, London or New York, you must show you're working. Well, I think in this question, there are various different ways of doing it, but I think one way to do this question is to use these ratios to help us find out the cost of 1 litre in both London and New York in dollars. So if we consider London, 1 litre is represented by, well, if I convert this into pounds by dividing by 100, we have 1.089. And if we find out what the equivalent is in dollars, of course, using this ratio, we need to divide by 1.46. Rather, we need to times by 1.46. So if I times by 1.46, this will convert the pounds into dollars. So we've got 1.089 times by 1.46. It turns out here, in dollars, the price of petrol in London for 1 litre is 1.58994. And we can do a similar thing with New York. So for New York, we know that 1 gallon costs, if we see the price here, we've got $2.83. Well, what we can do, recognizing that 1 gallon is 3.75 litres, we can see here that if we multiply by 3.785, you can see that 3.785 gallons would cost $2.83, rather, litres. And now to find out the cost of 1 litre, we would need to divide both sides by 3.785. So this tells us the cost of 1 litre. So if I do 2.83 divided by 3.785, it turns out here we get 0.747 etc. dollars for 1 litre of petrol in New York. And therefore we can conclude that New York is cheaper. Question number 3. A gold bar has a mass of 12.5 kilograms. The density of gold is 19.3 grams per centimeters cubed. You have to work out the volume of the gold bar. Give your answer correct to 3 significant figures. Well, first thing you will notice here, we've got kilograms here and grams here. So we need to convert the kilograms into grams, or vice versa. To go from kilograms to grams, we need to multiply by 1,000, and to go from grams to kilograms, we need to divide by 1,000. And therefore, 12.5 kilograms, multiplying that by 1,000, we get 12,500 grams. So therefore, the mass of the gold bar is 12,500 grams. Now, we know already the formula connecting volume to the mass and density, of course, volume is equal to mass divided by density. So therefore, the volume is equal to the mass, 12,500 grams, divided by the density, which is 19.3 grams per centimeters cubed. So if we work all of this out, we've got 12,500 divided by 19.3. It turns out we get 647.6 etc. centimeters cubed. So we get 648 centimeters cubed, correct to 3 significant figures. Question 4. There are only blue pens, green pens and red pens in a box. The ratio of the number of blue pens to the number of green pens is 2 to 5. The ratio of the number of green pens to the number of red pens is 4 to 1. There are less than 100 pens in the box. What is the greatest possible number of red pens in the box? Well, if we take a look at the ratio of blue to green to red, well, if we consider the ratio blue to green, that's 2 to 5, and green to red, that's 4 to 1. Now, here, it will make sense for us to get the greens the same. The lowest common multiple of the 4 and the 5 is 20. So we've got 20 over here, and then if I multiply the 5 by the 4, I get 20. If I multiply the 4 by the 5, I get 20. So 2 times by 4, that's 8. And 1 times by 5, that's 5. So therefore, the ratio of blue to green to red is 8 to 20 to 5. Now, we were told that there are less than 100 pens in the box. So with this, first of all, we can find the total number of parts. 8 plus 20 plus 5, this is 33. So we have 33 parts, and therefore, let's consider the 100. 100 divided by 33 gives us approximately 3 pens per part. And now if we multiply 3 by 5 to find out the number of red pens, we've got 3 multiplied by the 5, which is 15. So we have 15 red pens. Question 5, part A. You have to find the value of the reciprocal of 1.6. Give your answer as a decimal. Well, the reciprocal means 1 over. So the reciprocal of 1.6 is the 1 over 1.6. And if we work this out, 1 over 1.6, that's 5 over 8, which is 0.625. So we've got 0.625. We've got 0.625. And now for the next part, Jess rounds a number x to 1 decimal place. The result is 9.8, and we have to write down the error interval for x. Well, the error interval, we've got the lower bound, which is less than or equal to x, which is less than the upper bound. If we find out what the lower bound is, the lower bound is equal to 9.8 9.75, whilst the upper bound is equal to 9.85. And therefore for the error interval, we've got 9.75, which is less than or equal to x, which is less than 9.85. Question number 6. Here is a rectangle. The length of the rectangle is 7 centimeters longer than the width of the rectangle. 4 of these rectangles are used to make an 8-sided shape, as we see here. The perimeter of the 8-sided shape is 70 centimeters, and we have to work out the area of the 8-sided shape. Well, let's take this statement at a time. The length is 7 centimeters longer than the width. So if we say that this is x, then 7 centimeters longer than that, here we've got x plus 7. So if we amend this diagram, we've got the x plus 7 here, we've got x plus 7 here, and we've also got x plus 7 here, and we've got x plus 7 here. We've got x here, we've got x here, we've got x here, and we've also got x here. So this length over here will be 7 plus x, take away the x, which is just 7. So here we've got 7, and here we also have 7. So if we find out the perimeter, for the perimeter we've got x plus x plus x plus x, so that will be 4 lots of x. Rather, here we've got 4 lots of x, and then we've got x plus 7 4 times, so we've got 4 lots of x plus 7, and then we've got 7 twice, so we've got 2 lots of 7, and it turns out here we get 70 centimeters. So we've got 4x plus another 4x, so that's 8x. And then we've got 4 times by 7, which is 28, plus 14, that's 42. So we've got 8x plus 42 equals 70. So 8x equals 28. And therefore x is equal to 3.5. So how does this help us? Well, if we now draw a rectangle, what we've got here is 3.5 centimeters, and here we've got 3.5 plus 7, which is 10.5, and therefore the area of one rectangle is 3.5 times 10.5, which is 36.75, and therefore for the 8-sided shape we've got 4 lots of this area here, and therefore the total area this is equal to 4 lots of 36.75. So if I times that by 4, we get 147. So we've got 147 centimeters squared. Question number 7. We have to work out 13.8 times 10 to the 7 multiplied by 5.4 times 10 to the minus 12, and we have to give our answer as an ordinary number. Well, here, if we work this out on our calculator, we've got 13.8 times 10 to the 7 multiplied by 5.4 times 10 to the minus 12. So it turns out here we get a value of 7.452 times by 10 to the minus 4. So now we need to write this as an ordinary number. Well, so far we've got the 7.452, and remember, if this is in standard form, what we need to do is move the decimal place 4 units to the left. So we've got 1, 2, 3, 4 units to the left. So the decimal point goes here now, and here we've got 0.00075452. So as an ordinary number, we've got 0.0007452. Question number 8. When a drawing pin is dropped, it can land point down or point up. Lucy, Mel and Tom each dropped the drawing pin a number of times. The table shows the number of times the drawing pin landed point down and the number of times the drawing pin landed point up for each person. And Rachel is going to drop the drawing pin once, and for part A, whose result will give the best estimate for the probability that the drawing pin will land points up. Well, if we take a look at how many points up we get for each person, well, what we can do actually is find out the total number of throws each person had. 31 plus 14, that's 45. 53 plus 27, that's 80. 16 plus 9, that's 25. And therefore what we can see, Mel will give the best estimate because she had the greatest number of throws of 80. And now for part B, Stuart is going to drop the drawing pin twice. We have to use all the results in the table to work out an estimate for the probability that the drawing pin will land point up the first time and point down the second time. So what we can do over here is, well, if we work out the total number for point down, 31 plus 53 plus 16, that's 100. And 14 plus 27 plus 9, that's 50. So the probability of landing pin down, that's equal to 100 over the 150, which is the total. So the total here is 150. So we've got pin down, which is 100 over 150. And of course here, this is the same as 2/3. The probability that we land pin up, that's equal to 50 over 150, which is 1/3. So therefore, the probability that we get pin up and pin down, that's equal to 1/3 multiplied by 2/3, which is 2 over 9. So we get 2 over 9. Question number 9. Jack bought a new boat for £12,500. The value V pounds of Jack's boat at the end of n years is given by the formula. V equals 12,500 times 0.85 to the power of n. At the end of how many years was the value of Jack's boat first less than 50% of the value of the boat when it was new? Well, if we find out 50% of the 12,500, 50% of 12,500, this is equal to 6,250. So we're trying to find out how many years it will take to get a value less than this. So first of all, when n equals 0, we'll have 12,500. So when n equals 0, v equals 12,500. When n equals 1, if we work out what v is, we've got 12,500 times by, well, here what we can actually do is create a table. Here we've got 12,500 times by 0.85 to the power of, well, here we'd have x. We're starting at 1, and let's just end at 10 for now. Here when n is 1, we get v equals 10,625. N equals 2. V equals 9031.25. N equals 3. V is equal to 7676.5625. N equals 4. V equals 6525.07. 8125. And when n is 5, V is equal to 5546.316406. Now, what you'd also find here, this value here is less than this value here. So this is less than the 6250 that we found over here. And therefore, you can see it will take 5 years. And now for part B, a savings account pays interest at a rate of R% per year. Jack invests £5,500 in the account for 1 year. At the end of 1 year, Jack pays tax on the interest at a rate of 40%. After paying tax, he gets £79.20. We have to work out the value of R. Well, what we can do is find out the interest before the tax. If he pays tax at 40% and he has £79.20 left over, that means 60% would correspond to the £79.20. And we need to find out what 100% is. So we can first of all find out what 10% is. Of course, here we would have to divide by 6. So if I divide through by 6, then 79.2 divided by 6, this is 13.2. So we've got £13.20, and if I now multiply by 10 on both sides, then we've got 100%, which is 13.2 times by 10, which is £132. So this £132 This would represent the interest before tax. So, if we pay interest at a rate of R% per year and we originally invest £5,500, that means that we have R% of the £5,500, which is equal to 132. So this statement refers to him paying interest at a rate of R% per year. And of course we get £132. So this of course is the interest before the tax. So we need to find out what R is. Well, here we have R over 100 equals 132. Rather, we've got R over 100 times by 5,500 equals 132. So we've got 132 times by 100 divided by 5,500, which is 2.4. So R equals 2.4, so we have 2.4%. So here we've got just R equals 2.4. Question number 10. There are only blue counters, yellow counters and green counters and red counters in a bag. A counter is taken at random from the bag, and for part A we have to find the probability of getting a red counter. Well, we know that probability adds up to 1. So we've got probability of blue, which is 0.2, plus probability of yellow, which is 0.35, plus probability of green, which is 0.4, plus probability of red. All of this is equal to 1. And therefore, if we rearrange for probability of red, you'd find that to be 0.05. So we've got 0.05 for the probability of obtaining a red. Now for part B, what is the least possible number of counters in the bag? You must give a reason for your answer. Well, if we take a look at these probabilities, the smallest one is the probability of getting a red. And of course, the probability of getting red is equal to 0.05, and if I work that out as a fraction, that's 1 over 20. So what we're saying is, there is at least 20 counters in the bag, one of which is a red. Of course, we can unsimplify this fraction, which will tell us that there are more counters, but in the simplest form, the number of the probability of getting a red is 1 over 20, and therefore there must be 20 counters minimum in the bag. Question 11. The cumulative frequency graph shows information about the weights of 60 potatoes, and for part A we have to use the graph to find an estimate for the median weight. Well, if we've got 60 potatoes, 60 divided by 2, this is 30. So we want the 30th value. So if we find out where the 30th value is, that will be over here. So here is 30th, and if we find out the corresponding weight of this, then we've got here 57 grams for the median weight. Now for part B, Jamil says 80 take away 40 is 40, so the range of the weights is 40. Is Jamil correct? You must give a reason for your answer. cumulative frequency is for group data, and therefore he could be incorrect because the maximum, if we look over here, is less than 80, which corresponds to this over here, this weight, and the minimum, if we take it over here, is less than 40. So now for part C, we have to show that less than 25% of the potatoes have a weight greater than 65. So if we go back to the cumulative frequency diagram, 65 is over here. Okay, so if we draw a horizontal line up, here is our 65, and if we find out the corresponding cumulative frequency, so let's just do that. The corresponding cumulative frequency is over here. What you can see is for 65 grams, the cumulative frequency is equal to 49. So how does this help us? Well, what we can see here, if we've got 60 potatoes in total, then we can see is that there's 60 take away 49, which is 11 potatoes with a weight greater than 65. Now if we work out 25% of 60, that's of course equal to 15. And so for the top quartile, we've got 60 take away 15, which is 45. So therefore, with a cumulative frequency of 45, if we go back to our diagram, we've got 45 over here, and if we draw the vertical line going downwards, over here, then what you can see here is we've got 63 grams. So what does this mean? Well, it means that 25% of the potatoes have a weight greater than 63. So if we work out the percentage, then here we've got 11 over 60 multiplied by 100. So we've got 11 over 60 times by 100, which is 18.3, etc. %. And of course, this is less than the 25%, and that's exactly what we wanted to show. Question number 12. Alan has two spinners, spinner A and spinner B. Each spinner can land on only red or white. The probability that spinner A will land on red is 0.25, and the probability that spinner B will land on red is 0.6. And the probability tree diagram shows this information, so that's what we see here. Alan spins spinner A once and he spins spinner B once. He does this a number of times. The number of times both spinners land on a red is 24, and we have to work out an estimate for the number of times both spinners land on white. Well, if we find the probability of two reds, we have here 0.25 times by 0.6, so let's work that out. 0.25 times by 0.6, it turns out here we get 0.15. So what does this 0.15 mean? Well, it means landing on a red 24 times. So it would represent landing on a red 24 times, and we want to work out an estimate for the number of times both spinners land on white. So first of all, probability of landing on a white twice, that's equal to 0.75 times by 0.4. So we've got 0.75 times 0.4, which is 0.3. So this 0.3, well, we have to find out how many times we land on a white. So we want to find out what this 0.3 would represent in terms of landing on a white a certain number of times. And you can see to go from the 0.15 to the 0.3, we have to multiply by 2. So if we multiply the 24 by 2 as well, we would get 48. So therefore, we land on a red 24 times and we land on a white 48 times. Question 13, we have to write x squared plus 6x minus 7 in the form x plus a all squared plus b, where a and b are integers. Well, here clearly, to express this quadratic in this form, we have to complete the square. So first of all, we halve the coefficient of x. Half the coefficient of x is 3. So we have x plus 3 all squared. Then we subtract off the square of 3. And then we've still got the minus 7. So we've got x plus 3 all squared minus 9 minus 7. Of course, we've got x plus 3 all squared minus 16. So we've got x plus 3 all squared minus. Question number 14. Cone A and cone B are mathematically similar. The ratio of the volume of cone A to the volume of cone B is 27:8. The surface area of cone A is 297 centimeters squared, and we have to show that the surface area of cone B is 132 centimeters squared. So here we've got the cones. We've got cone A and cone B, and what we can do over here is, first of all, recognize that to go from the small shape to the big shape, we need to multiply. To go from the big shape to the small shape, we of course need to divide. If we find out the volume scale factor, the volume scale factor is equal to 27/8. So we've used the ratio to express that in an equivalent fraction. So with this, we can find out the length scale factor, and once we've found out the length scale factor, we can find out the area scale factor. The length scale factor is equal to the square root, the cube root of 27/8, which is 3/2. And then the area scale factor is equal to length scale factor cubed, so rather length scale factor squared. So here we've got 3 squared, which is 9, 2 squared, which is 4. So the area scale factor is 9/4. We've been given that the surface area of A is 297, and therefore the surface area of B, that's equal to 297 divided by 9/4, So if we work this out on our calculator, we get 297 divided by 9/4, which is 132. So we have 132 centimeters. Question 15, part A, we have to show that the equation x cubed plus 7x minus 5 equals 0, and we have to show that this has a solution between x equals 0 and x equals 1. Well, first of all, we need to have something equal 0, and once we have that, we can define what f of x is. We can define f of x to equal x cubed plus 7x minus 5. And now we want to show that this has a solution between 0 and 1. So we begin by finding out f of 0. So we've got 0 cubed plus 7 lots of 0 minus 5, which is minus 5. And f of 1, that's 1 cubed plus 7 lots of 1 minus 5, which is 3. So what we see then is we have a change on sign. We're going from minus 5 to 3. And f of x is continuous in the interval from 0 to 1. And therefore we can conclude we've got a root alpha in between 0 and 1. And now for part B, we have to show that the equation x cubed plus 7x minus 5 equals 0 can be rearranged to give x equals 5 over x squared plus 7. Well, if I add the 5 over to both sides, we are left with x cubed plus 7x equals 5. If we now factorize, we've got x lots of x squared plus 7 equals 5. And if I divide through by x squared plus 7, we can therefore conclude x is equal to 5 over x squared plus 7. And that's what we wanted to show. And now for part C, starting with x naught equaling 1, we have to use the iteration formula xn plus 1 equals 5 over xn squared plus 7 3 times to find an estimate for the solution of x cubed plus 7x minus 5 equals 0. Well, first of all, we've been given that x naught is equal to 1. So we can find out what x1 is if we work out what x1 is. We've got x naught squared plus 7 on the bottom, and on the top we've got 5. So we've got the following. So we've got 5 over 1 squared plus 7. So if I work this out, well, I begin by typing in 1 into my calculator, and then I've got 5 over answer squared plus 7. So here I get 5 over 8, which is 0.625. So this is what I get for the next value. Okay, so let's just rub all this out. And then x2, this is equal to, so if I type all this into my calculator, what I need to do over here is, well, I've got 5 over x1 squared plus 7. So we've got the following. So if I press equals here, we get a value of 0.676, etc. Let's write out the, well, we'll leave it as it is. So this is the value of x2, and then x3, that's equal to x2 all squared plus 7 on the bottom, and on the top we've got the 5. So here we've got 0.676 etc. squared plus 7, and then on the top we've got the 5. So if I work this out, press equals again, we get 0.607670 etc. So this is the value of x3. Okay. So now, if we were to write out the full solution, we've got x equals 0.6704483,001. That's the full solution. And now for part C, by substituting your answer to part C into x cubed plus 7x minus 5, we have to comment on the accuracy of our estimate for the solution to x cubed plus 7x minus 5 equals 0. Well, let's take a look at our answer. That's what we got previously. And if I substitute this into here, well, we've got the 0.670 etc. to the power of 3 plus 7 lots of 0.670 etc. minus 5. So if I work this out, I've got this cubed plus 7 lots of this minus 5. And it turns out here we get minus 5.49 etc. times 10 to the minus 3. Well, how does this help us? Well, this value over here is close to 0, so we have a good estimate. So because this is close to 0, we have a good estimate. Question number 16. The petrol consumption of a car in litres per 100 kilometers is given by this formula here. Petrol consumption is equal to 100 times the number of litres of petrol used over the number of kilometers travelled. Nathan's car travelled 148 kilometers, correct to 3 significant figures. The car used 11.8 litres of petrol, correct to 3 significant figures. And Nathan says, my car used less than 8 litres of petrol per 100 kilograms. Could Nathan be wrong? You must show how you get your answer. Well, here we want the petrol consumption to be as large as possible. The answers have been rounded to a certain degree of accuracy, so of course here we need to use bounds. So if we consider the distance, the upper bound of the distance, that's equal to 148.5, and the lower bound of the distance is equal to 147.5. The upper bound of the litres of petrol used, that's equal to 11.85, and the lower bound of the litres of petrol used, that's equal to 11.75. Now we want the upper bound, so therefore the upper bound of the petrol consumption, this is equal to 100 multiplied by the upper bound of the number of litres used over the lower bound of the distance. Okay, so here we've got, if we work all this out, we've got 100 times by 11.85 over 147.5. So if we work out what this is, we've got 100 times 11.85 over 147.5, so we get 8.03 etc. And of course, because this is greater than 8, what we can conclude then is Nathan could be wrong. Question number 17. ABC and ADC are triangles, that's what we see here. the area of the triangle ADC is 56 centimeters squared, and we have to work out the length of AB, giving our answer correct to 1 decimal place. Well, first of all, we can find the missing angle BAC. Of course, BAC is equal to 180, take away 118, take away 48, which is 14. And the reason for this angle here being 14 is because angles in a triangle sum to 180. Now we know that the area of this triangle here, the area of the triangle ADC, is equal to 56 meters squared. So we've got 1/2 times by 11 times by CD times by the sine of 105 degrees. This is equal to 56, and if we find out what CD is, this can help us a bit more. So if we find out what CD is, we've got over here on the bottom 1/2 times by 11 times by sine of 105, and on the top here we've got 56. So if we work all of this out, we've got 56 over 1/2 times by 11 times by the sine of 105. So we get over here 10.54, etc. So here we get 10.54, etc. And let's add this to our diagram. We've got 10.54, etc. meters. Now, what we can do, because we've got an angle and two lengths in between the angle, we can find out what AC is. So we can find out what AC is using the cosine rule. So let's just store this into A. AC squared is equal to 11 squared plus 10.54, etc. squared minus 2 times by 11 times by 10.54, etc. times by the cosine of 105. So if we work out what this is, we've got 11 squared plus this squared minus 2 lots of this times by 11 times by the cosine of 105, and then we square root this. So here we get AC. Well, here AC squared is equal to 292.1, etc. So therefore AC is equal to the square root of this, which is 17.09, etc. meters. So if I add this to the diagram, I've got 17.09, etc. meters. And what we have to do in this question is find out what AB is. So if we find out what AB is, well, of course here we can simply use the sine rule. So if we consider the triangle ABC, and if we work out what that is, we've got the AB over the sine of 48, which is equal to the 17.09, etc. over the sine of, if I go back to the diagram, 111, rather 118, what we can now do from here is find out what AB is. So AB, that's equal to 17.09, etc., times by the sine of 48 divided by the sine of 118. So if I work out what AB is, I've got this multiplied by the sine of 48, and then I'm going to divide this by the sine of 118. So it turns out we get 14.38, etc. So therefore AB is equal to 14.4 meters given to 1 decimal place. Question 18, here is a speed time graph for a train, that's what we see here. And for part A we have to work out an estimate for the distance the train travelled in the first 20 seconds, and we have to use 4 strips of equal width. So if we split this up, let's split it up here. We also split up here, here, here. So here we've got 4 equal strips. And then what we need to do is join all these together. Okay, so let's just get a straight line, and if we join these together, you can see that the trapezia are over the curve. So what we need to do is first of all recognize that the distance is the area under the curve of a speed time graph. So we need to find out the area of each of these segments. First segment, well, of course, here we've got a triangle, so we've got area of 1 being, well, let's just do it all in different colours. So here we've got 1. Area of this is 1/2 times base, which is 5, times by height, which is 2. Area of this second segment, that's 1/2 lots of 2 plus 5 lots of 5. Area of this third segment, we've got 1/2 times by 5 plus 10 times by 5, and area of this fourth segment, we've got 1/2 times by 10 plus 18 times by 5. And then of course we need to add all these together, and that will give us the distance. So therefore the distance is 130 meters. So we've got 130 meters, and now for part B, is our answer to part A an underestimate or an overestimate of the actual distance the train travelled, and we must give a reason for our answer. Well, the trapezia are over the curve, and that's exactly what we saw in red over here. So the trapezia are over the curve, and therefore we have an overestimate. Question number 19, we have to prove algebraically that the straight line with equation x minus 2y equals 10 is a tangent to the circle with equation x squared plus y squared equals 20. So what we can do over here is, well, to show that a line is a tangent to the circle, the intersection, the line must intersect the circle exactly once. So if we call this first equation, equation 1, So if we call this first equation 1, and if we call this second equation 2, then we know here from equation 1 we can rearrange to say that x equals 2y plus 10. We will call this equation 3. So now we will substitute in equation 3 into equation 2. So if we do that, we've got x squared, so we've got 2y plus 10 all squared plus y squared. This is equal to 10. Rather, this is equal to 20. So now we need to expand and simplify all this. Well, 2y all squared, that's 4y squared plus 40y plus 100 plus another y squared we've got from here, and all of this is equal to 20. So if we gather all the terms on one side, we've got 5y squared plus 40y plus 80 equals 0. And if we divide through by 5, of course you can see y squared plus 8y plus 16 equals 0. And if we attempt to solve this, well, we can factorize this as a perfect square. So we've got y plus 4 all squared equals 0. And therefore, we've got y equals 4, y equals minus 4, which is our only solution. So this here is a repeated root. So when y equals minus 4, we can find out the corresponding x coordinate by substituting into equation 3. So we've got x equals 2y, so we've got two lots of minus 4, plus 10, so we've got minus 8 plus 10, which is 2. And therefore, equation 1 intersects equation 2 exactly once at 2 minus 4. Question number 20. We've got A, B and C, which are points on the circumference of a circle with centre O, and AOB is the diameter, and we have to prove that the angle ACB, that's this angle here, is 90 degrees. You must not use any circle theorems in your proof. Well, first of all, if we have a line over here, then what you can see is OA, so the line OA equals the line OB equals the line OC. So this is equal to this, which is equal to this. And the reason for that is they are all radii. So they are all radii. And because they are radii, because this length equals this length and this length equals this length, what we can conclude is that triangle OAC and OBC are isosceles. And the reason for this, of course, we've got two sides of equal length, okay? So what we can conclude then is well, if we consider the triangle OAC, so if we consider the triangle OAC, then the angle, or we'll do this in a different colour, the angle OAC will of course equal the angle OCD, CA, which will equal x. So what we're going to do over here is let x equal this. So we're going to let these equal each other. So this one is x, and this one is also x. And that's of course because base angles in an isosceles are equal. So base angles in an isosceles triangle are equal. And now if we consider the triangle OBC, then what we will do over here is we will let the angle OBC equal the angle OCB equal y. So what we're saying here, this angle is y, and this angle is y. So let's write down the reason for this. Of course, base angles in a triangle are equal. Now, if we consider the triangle ABC, then what you can hopefully see here is angles in a triangle sum to 180. So we've got x plus, so that's this x here, plus x plus y plus y. All of this equals 180, and the reason for that, of course, angles in a triangle sum to 180. So if we tidy this up, we get 2x plus 2y equals 180, and if I divide through by 2, x plus y is equal to 90. But this over here is actually the angle ACB over here. So let's just make this smaller. So this is ACB. Okay. And therefore, that's exactly what we wanted to show. So let's just write that down. Hence shown. Question 21. OAN, OMB and APB are straight lines. AN is twice OA and M is the midpoint of OB, and we're given that OA is equal to A. So here we have A. So here we would have 2A because AN is twice OA, so here we've got 2A. And we're given that OB is little b, so because M is the midpoint, here we have 1/2 B, and here we have 1/2 B. And we're also given that AP, that's this vector here, is equal to k lots of the vector AB, where AB is a scalar quantity, and given that MPN is a straight line, we have to find the value of k. Well, first of all, if we find out what the vector AB is, the vector AB starting at A, finishing at B, that's equal to AO, which is, well, let's just write this down. We've got AO plus OB. So we've got AO, which is minus A, and then we've got OB, which is positive B. Now, since MPN is a straight line, That means MP and PN are parallel to MN. Let's just write that down. So as MPN is a straight line, okay, so as MPN is a straight line, MP and PN is parallel to MN. So how does this help us? Well, if we find out what AP is K lots of AB. We already know what AB is, we found it over here. So we've got K lots of minus A plus B. In other words, we've got minus K A plus K B. And then we've got MN. If we work out what MN is, starting at M, finishing at N, well here we've got, well let's just write out the full thing. We've got MN, which is equal to MO plus ON. So MO, that's minus a half B. And then ON is 3A because we've got A plus 2A. So that gives us 3A. And what you'd find over here is, in conclusion, that the ratio of A to B is equal to 6 to minus 1. You can see here the value of the A vector is 6 times the value of the B vector, and of course we've got the minus here to take into account the minus 1/2 B. So this will help us because this ratio will be true for all vectors parallel to MN. So this ratio is true for all vectors parallel to MN. And we also know that the vectors parallel to MN are MP and PN. So if we consider PN, the vector PN starting at P, finishing at N, well we've got PA plus AN. So we've got PA plus PN. So this is what the vector, rather here, PN is equal to PA plus AN. So how does this help us? Well, PA, that's going to be minus K lots of AB. So that's going to be minus this value here, so that's going to be, well, I need to flip the signs here, so I've got KA minus KB, and then AN, starting at A, finishing at N, that's 2A. So if I tidy all of this up, gathering all the terms involving an A, we've got K plus 2, lots of A plus 2, rather minus KB. So we've got minus KB. So how does this help us? Well, if we use that ratio, then what we can see here then is we've got the ratio of A to B, that's equal to 6 to minus 1. So therefore, what we've got then is A over B, the A component over the B component. So here we've got K plus 2 over the minus K. This is equal to 6 over minus 1. And the minuses cancel out. So we're left with if we rearrange as well, first of all, minuses cancel out. So we're left with multiplying through by k as well. K plus 2 equals 6k. So therefore, 5k equals 2. So therefore, k equals 2/5. So we've got k equals 2/5.